Okay, let us see potassium dichromate. Okay. So what is potassium dichromate? It has its own formula K2Cr2O7. Right. So you know that it is one of the most important compound of chromium. Right. So what is the valency of the chromium? Huh? How it is 6? குரோமியமோட நார்மலா வெறும் இண்டிவிஜுவல் எலிமெண்டா நீங்க எடுத்தீங்க அப்படின்னா what is the valence of a chromium? In this compound it is 6 plus 6. Right. The valency of the chromium in this compound is 6. How can you say in this compound is 6? You have to find the oxidation state. That is not a problem for you. Seems right. So what is the actual oxidation state of an element? Plus 3. Is it clear? Then so what it is given, so first one is given as a use. I'll explain you about this. Let us see. In your book it is given so clumsy. Okay, I'll explain you this. Take down the notes. Preparation. Preparation. Okay. So many methods you can prepare. From potash alum. Sorry, potash chromate first we will learn. From potash chromate. Okay. So potassium dichromate can be obtained. I'll write in this. I'll open here the book. Is it clear for you? This page. Okay. Potassium dichromate. Just do write it. Potassium dichromate. Is obtained by adding calculated amount of sulfuric acid to a saturated solution of potassium chromate. To a saturated solution of potassium chromate. So how can you write the reaction? Write the reaction now. So what is the reaction? You write the reaction. So what is the potassium chromate? What is the molecular formula for potassium chromate? So first of all, so how it is prepared, everything we need to understand. So what is the formula? K2 in the presence of H2SO4. It gives K2 Cr2O7 plus K2SO4 plus H2. So it should be 2 times, right? Then only you'll be getting these two compounds. Okay. So our aim is to prepare potassium dichromate. This is one method. Okay. Is it clear? But initially you are not given directly the potassium chromate okay, to the potassium dichromate. The potassium chromate is not the stable compound. It can be prepared only from sodium chromate. Okay. From the sodium chromate, we can convert potassium dichromate. Okay. Always, sodium is the very easy compound which is easily mingled with the chromate solution. Okay. So when compared to potassium. So that it is seen to be very important. Potassium dichromate potassium mix in the presence of H2SO4 is not an easy job. Okay, in the saturated solution of potassium chromate, that is what it is given, right? So first, sodium chromate only prepared. From the sodium chromate, potassium chromate is prepared, and then that is converted into potassium dichromate. Okay. So then we are going to see from chromate ore. What is the chromate ore? What is the ore of the chromate? What is the molecular formula? First one is this one. Second one, from chromite ore. So, what is the molecular formula? It's given in your book, right? What is the chromate ore? FeCr2O4, right? So, K2Cr2O7 is generally manufactured from chromate ore. So, how it is manufactured? All the reactions are given in your book, right? So, preparation of sodium chromate first. As I told you, no. So, you have to prepare first sodium chromate. That is prepared first. So, finally, chromate ore is mixed with soda ash, right? And then quicklime. Okay, the mixture is then roasted in a reverberatory furnace in the presence of air. So you always connect everything to the kitchen things. How we are roasting something in the kitchen, that's the kind. That kind. Okay. So the furnace is called reverberatory furnace so that the other thing should not get into this. So some oxidation, some pollutants will not enter into the furnace. So that it is said to be so many different types of furnaces, you know, right? Okay. So preparation of sodium chromate can be done in this way. And then what is the product? Sodium chromate is obtained. What is the color of that? Yellow. So yellow mass is obtained. So many reactions are given, right? What are the reactions given? What are the reactions given? What is that? Read பண்ணுங்க. இதுதான் the reaction. Yeah. 4 FeCr2O4 plus 8 Na2CO3. Right. Then plus 7O2, it gives 8 Na2CrO4 plus 2 Fe2O3 plus 8 CO2 it is given, right? So I will tell you easily. So what is given? Chromite ore is now mixed up, right? So what is the chromite ore? 4 FeCr2O4 plus it gives plus oxidation. So when it gets roasted, then what happens? It gets oxidized. So it gives what? 2 Fe2O3. 2 Fe2O3 plus what is the remaining? 4 Cr2O3. Okay? We are splitting 6 plus 12 oxygen. 6 plus 12 oxygen. This is first it is the process. After that, this 4 Cr2O3, it mixed up with 8 Na2CO3, okay, plus 6 oxygen, because excess here it says, right? Then it gives 8 N2CrO4 first, plus the remaining will be 8 CO2 it is given. Okay. Now check the balancing equations, whether it is get balanced or not. After that, the reaction follows 4Fe2, Cr2O4. Again, these two combined with excess oxygen. Got the point? Okay. Then it will give 8 Na2CrO4 plus 2 Fe2O3 plus 8 CO2. So this is the yellow mass which is extracted with water. Okay. And filtered, the filtrate contains sodium chromate. Okay. So this reaction can be carried out by sodium hydroxide also. Is it clear for you? Instead of Na2CO3 can be carried out by means of sodium hydroxide also. Okay. So can we write that equation also? It is not given in your book. You can write it. It can also be carried out like this. By using sodium hydroxide. So in this, instead of Na2CO3, we are going to write sodium hydroxide. So what is the reaction might be? 4 Fe Cr2O4 plus here for the balancing it will become 16 NaOH plus excess of oxygen 7O2. It gives again 8 Na2Cr O4 plus 2 Fe2O3 plus 8 H2. Got it? Clear? Write this reaction also in your book. See, actually, it is less soluble, and then it can crystallizes out. That is its property. Yeah. Mainly, this is filtered hard. How it crystallizes? It is allowed to cool. It is settled down to crystal. Okay, by allowing it to cool. So usually gets filtered as a hard, liquid state. It will be okay, but after cooling it becomes crystal. Why it is? Just less soluble. That is the meaning. Okay. So then what is given? Sodium dichromate is more soluble than potassium dichromate. So when compared to potassium dichromate, which is more soluble? Sodium. Okay. So the latter is therefore prepared by treating the solution of sodium dichromate with potassium chloride. So initially, what is the problem? Potassium dichromate is less soluble. So that it crystallizes out by means of this process. Okay. So many preparation you have to learn through. Okay. Then sodium chromate, when compared to that, it is highly soluble. It is treated with KCl, right? Or it is given this reaction is treated with KCl, then it gives potassium dichromate plus NaCl. Because right? Okay. Then we'll go through this. So what is the color of the potassium dichromate? Orange. Okay. Which one is yellow? Sodium chromate. Potassium dichromate is orange precipitate. Okay. So the chromates and dichromates are interconvertible. Listen, the chromates and dichromates are interconvertible. Easily, right? It becomes aqueous also. So mostly it is orange red crystals. It melts at 699 Kelvin. It melts at 699 Kelvin. Okay. Then so it can be reacted with high excess of oxygen, right? So we can say it is very stable in air. Then what are all the physical properties discussed over here? Okay. So, and then even then it is less soluble in water. Even then its solubility is limited. But it is soluble. So that it crystallizes out. Right. Okay. So we'll see the chemical properties which discussed. So first write in your notebook. So you know the structure now, right? Chromate ion and dichromate ion. So dichromate is like a I mean, it's really like a butterfly, right? Okay. You can imagine in a way. It's like a butterfly structure. This is chromation. Okay, what is the chromation formula? What is the formula for chromation? Clear? Okay. So if it is O4, then how the ions are tallied here? Chromium has, you said 6, right? Then how the ions are tallied? How the oxidation state, it becomes 2 minus. Hmm. So how can you write the structure? How it is mingled? How it is mingled? So first of all, so what is the resultant of action of heat, ma? What is the resultant of action of heat? K2Cr2O7 becomes, it is interconvertible, right? Dichromate becomes chromate. Okay. So, and then action of acids are given. Right. So what are all the acids mixed up? As we have discussed now, the acid is mixed up, then what happens? H plus will interact with the K2Cr2O7. Right. So many reactions are given, but in this it is not given clearly. So here the structure is discussed, and then I'll give you the reactions. You just put the heading as chemical properties. The heading is chemical properties. I'll explain you about the chemical properties, right? So action of acids you put. What is the first acid we can see? With concentrated sulfuric acid. In cold. Okay, cold concentrated sulfuric acid. Red crystals of red crystals of chromium trioxide is separated out. That means filtered and get cold. Okay. So K2Cr2O7, it is now aqueous. Very important. Okay. Plus corn sulfuric acid. It gives KHSO4. K plus will becomes KHSO4. Then 2CrO3 solid. It is solid. All ions. Okay. So on heating a dichromatic sulfuric mixture, oxygen gas is given. Again, it will be heated, right? So if you heat this, then 8H2SO4, 2K2SO4 plus 2Cr2. So this becomes, okay, 2Cr2SO4 thrice chromium sulfate. Then that is chromium trioxide. Again, if it is heated with sulfuric acid, then what happens? It becomes chromium sulfate and the oxygen is liberated. Okay? With HCl we took, right? So with HCl, you know. Then what is the action of alkalis? Dichromate plus What is the alkali? KOH. NaOH I told, right? So like that, we can include KOH. Write the reaction for KOH. Plus KOH. What will happen? It becomes chromate. Potassium chromate. That's it. Okay. So it is yellow, right? Orange becomes yellow. So again, if the potassium dichromate is acidifying, potassium chromate is acidified, then what happens? It again changes into orange color. That you know, right? So it is interconvertible. Okay. Then what else given in your book? Okay. So in dichromate solution, it these two, I mean, you can take like this. Cr2O7 2 minus, right? It is now in equilibrium with Cr2O7 2 minus ions. How? How we can say? Sorry, O4 2 minus. O4 2 minus. It is now equilibrium with O7 2 minus. How can you say it? Now only we have discussed, right? With the help of H plus ions. So that it needs to mingle with alkalis. Okay. When it is mingled with acid, then what will happen? Oxygen is coming out. So it will become chromium oxide, trioxide like that. So it won't give you a perfect dichromate. Okay, so that follows so many steps. But with alkali, definitely these two maintain equilibrium. What are the equilibriums? Cr2O7 2 minus plus we can say this potassium dichromate, if it is mingled with water, then it will give 2Cr2O7 2 minus also. So water also neutralizes it. And then now the equilibrium takes place. Not neutralization. Dichromate and chromate will be in equilibrium when mixed up with H plus ions. So by means of acid, by means of alkalis, by means of water also we can do this. Okay, this is the very good nature of this. Then we are going to discuss about, yeah, the time is there. So oxidizing nature. Put this oxidizing nature. What is the oxidizing nature? Oxidizing means oxidation. What is the oxidizing agent? Self-reduced. Right. That means it reduces, I mean, it reduces means what is the meaning? Oxygen is removed from that. So oxygen, how it reduces? Cr2O7 2 minus gets reduced to bring the charge. Yeah. Reduced to Cr3 plus. Right. That means the oxygen is removed from there. Okay. By means of electrolytic process. That is discussed in your book, right? What is the electrolytic process? Hmm? What is the standard electrode potential given in that, in your book? What is the standard 1.31? 33 volt, right? So the standard electrode potential is 1.33 volt, right? So that is Cr2O7 2 minus. It gets, if it wants to get reduced to 3 plus, then it needs 14 plus 6 electron. Because how many oxygen is there? O7 means It needs 14 electrons. Right? So 14 plus, then where it comes 6 electron. Chromium is 2 minus, right? So 2 plus 6. So it gives what? 2 Cr3, sorry, Cr3